All right, so final section of notes here. We got 7.3. We spent a couple days on this. So 7.3 is trigonomic functions and real numbers. So the real goal here is I can use reference triangles to find trig values or ratios. We'll go with values. I think makes the most sense. So we're going to be basically focusing on reference triangles in the unit circle and using that to come up with different ratios. And we're going to learn a couple identities, but we'll get to that later on. All right. So what are the sine and cosine of the angle 2 pi over 3? All right. So let's do like we did the other day, and let's sketch where that's going to be. So 2/3 of a pi. So we know a full pi would take us to here. 2/3 of a pi is going to take us 2/3 of the way. So it's going to be roughly here. Ooh, that's a bad line. My bad. Okay, that's one line. All right. So that's 2/3 pi. For reference, this angle here, the reference angle, the one we care about, would be pi over 3, or 1/3 of a pi. So that's going to be our reference angle that we're going to use in this triangle. And so when they ask us what are the sine and the cosine of that angle, this angle is above 90 degrees. You know, sine, cosine, tangent within the triangle work for these acute angles. So we can work with this triangle, figure out our sine and cosine of this angle using what we know. So remember, this is the unit circle, so this is a 1. Pi over 3 is 60 degrees, right? Because if this is 180 degrees is pi, divided by 3, this is 60 degrees. So we've got a 30, 60, 90 here. So we can look at this. We know the hypotenuse is 1. We know that this is my small angle, so this is going to be a half or 0.5. And this is going to be 1/2 times root 3, or in other words, just root 3 over 2. And we come up with all those just knowing our special right triangles. From here, we can say what sine of pi over 3 is going to be. And the reason why these are going to be equivalent is this coordinate is the same whether we use the terminal angle or the initial angle here, or we use the reference angle. So we can do sine of pi over 3, and that's going to be equivalent to sine of 2 pi over 3. Okay. So what is that going to be? Well, if we do sine of this angle, that's opposite over hypotenuse. That's root 3 over 2 over 1. So I don't need to put the over 1. There we go. There's that answer. And whoops, let's do cosine of pi over 3 is going to be equivalent to cosine of 2 pi over 3. And cosine is 1/2 over 1. So 1/2. Now, the one thing we do need to take into account here to make sure that, I guess these aren't technically equal. What I do need to, so I said that, but what we have to take into account is the position of this. So this does need to be, the x value needs to be negative, the y value needs to be positive. So this is actually going to be a negative 1/2 because we're going to the left in terms of coming up with this value. So just keep that in mind. But these are going to be our two values. Now, here's the thing about this that I want to make sure you're clear on, but I really don't want you to do the problems using the calculator, because I want you to understand your unit circle and understand the drawing of the triangle and the 30, 60, 90s and everything that kind of pieces together. The calculator is programmed to do this. If I were you, I would check them this way. Okay, could you do this and would I not know the difference? Yeah, that's true. But in terms of like learning this stuff for trig pre-calc for like next year and then other math classes you might have and stuff, you really want to understand how the unit circle and the reference triangle is all created. But if you want to check this and you want to say, okay, sine of 2 pi over 3, as long as I'm in radian mode, it's going to give me the right answer, which I believe I am because it looks right. Yeah, so I'm in radian. This is root 3 over 2. Yes, we do want it in radical form. So, maybe you know what this is because we've seen it a bunch of times. But yeah, you can check that answer out. You can see it is, in fact, the same thing. There you go. If you want to do cosine of the 2 pi over 3, you'll see it gives you the negative 1/2, and we're good there. So yes, these are in the calculator. You do need to be in degree mode. You need to be in radian mode because these are in radians. Unless you wanted to convert them to degrees, and you could say sine of 60 and 120. That'd be the same thing. So keep that in mind, though, but really try to understand this using your special right triangles and using your reference triangles, it's going to pay off in the end. Trust me, in terms of understanding it. If you want to check it with this, definitely feel free. I think that's the smart move. All right, so let's look at this one. What is sine and cosine of a 45-degree angle? Or sorry, negative 45. So negative 45 is going to go in this direction. So 45 is going to split this right down the center. That's the reference angle as well then. So this is a 45, 45, 90. On the unit circle, the radius is 1. And these are both going to be root 2 over 2. Okay? Because if you divide this by root 2 and you simplify it, it becomes that. So now what are my sine and my cosine? Well, sine of 45 is opposite over hypotenuse. So that's going to be root 2 over 2 over 1. What's cosine 45? Going to be root 2 over 2 over 1. Okay. And then I just need to double check my signs on these. So going to the right, my x is positive, my y is negative. So this one does need to be negative. Okay. And there we go. So remember how these do work. This is always your x, this is always your y. So like when you're solving for the value there, we do know that this is technically a negative. So when we're doing our sign, this is a negative. So you can label that on there right away. These do check out in the calculator as well. Now, because this is 45 degrees, you do want to switch back and forth to the correct mode. So go to degree. So sine of negative 45 is that value. Cosine of negative 45 is that value. So same thing. But again, get comfortable with doing it using the unit circle. It's really going to get you where you want to go. Okay. All right. With these ones, try drawing these out. See if you can come up with theirs. I'll do the same. Okay. So I set up part of this, but we'll go ahead and get into it. So 4 pi over 3 is going to be a full pi and then a third of a pi. So put it right here. Which means that this is a third of a pi. So pi over 3 is this reference angle. Same one we just did up here. So I actually looked right up here to look at my values and I knew, okay, yep, this is that 30, 60, 90 type triangle where it's a half and root 3 over 2. Same exact triangle, so a half and root 3 over 2. In this case, these are both negative values because they're going left and down. So when we go to figure these out, sine of my angle, opposite over hypotenuse, is going to be negative root 3 over 2. Cosine of this angle is going to be negative 1/2. And as you get to this, you're going to start noticing that this is just as quick, pretty much, just as quick as putting it in a calculator. And you're then understanding it. It's going to really help you with unit circle stuff in the future. So trust me on it. But again, feel free to check it in the calculator. Smart move. All right, this one, let's see what we got. So 3 pi over 4, so 3/4 of a pi. So that's half a pi. 3/4 of pi is going to be right off here. So that's 3 pi over 4, which means this is a 1/4 pi, or pi over 4. All right. So what do we have? Unit circle. This is 45 degrees, right? 1/4 of pi, 1/4 of 180 degrees is 45. So same one we just did, root 2 over 2. And in this case, we're going left, so that's negative. We're going up, so that's positive. All right, so sine of 3 pi over 4, cosine of 3 pi over 4 are, our sine is our opposite over hypotenuse, so that's just root 2 over 2. Our cosine is our adjacent over hypotenuse, so it's negative root 2 over 2. And that's it. We got them. Definitely not too bad. Very doable. You just got to get comfortable with your special right triangles and drawing these out. Okay. All right. Last piece we're going to look at today is, ooh, that's really blurry. I'm going to rewrite that. That's weird. Okay. Okay. So just to recap this, there is a thing called the Pythagorean identity. There's actually a ton of identities. This is one of the first. Sorry, we did a couple the other day, but this is one of the more important ones. And this is that sine squared theta plus cosine squared theta equals 1. When it's written this way, this is actually the same thing as saying sine theta squared, like this. But for whatever reason, honestly, I don't know. Maybe I should look it up sometime. They always write it here as like sine squared like this, but these are equivalent. These mean the same thing. This means cosine theta being squared, but it's always written this way. I'll have to look up why that is because I actually don't know why. All right, so it says, what is sine of theta if cosine of theta is negative 3/5? and theta is in quadrant 3. All right. This theta being in quadrant 3 part, we're going to worry about after we solve this problem out. So remember that it's a thing, but we don't need it right now. So this identity is just, we're told that it's always true. There's proofs you can do to show why it's true. We're not going to do that. But this is a true trig identity. So what we can do is anytime we have something like this and we want to figure out what sine of theta is, we can actually use this identity to solve for it. So if we have sine squared theta plus the cosine squared theta, but we know what cosine theta is, it's negative 3/5. So we can actually just substitute it in there because, right, this is cosine theta being squared. So I just replaced cosine theta with its value. And I'm going to actually be able to just solve this equation to come up with what sine theta is, because that's what this question is asking me. All right, so that's going to be, so we have sine squared theta plus, if we square this, that's going to be 9 over 25 equal to 1. And then we're going to subtract 9/25 over to here. Subtracting fractions, one of everybody's favorite things. Don't make this more difficult than what it is, all right? What I mean by that is you have 1 minus 9/25. Another way you can think of 1 is 25/25. So if you have 25/25 and you take away 9/25, you have 16/25 left, okay? That's creating a common denominator, but make it simple on yourself. Just realize it. Just make this whatever this denominator is, and it's super easy. Now we have sine squared of theta equals this. We just want sine, so go ahead and root both sides. So now we're going to have, put it over here, sine theta equals the square root of this, which is going to be the square root of 16 is 4, square root of 25 is 5. Now the problem is when you square root something, remember how you get plus or minus? So we need to figure out, is this positive or negative? And the way we answer that is we look at the quadrant. So this, if it's in quadrant 3, we think about it here. Okay, so we got sine of some theta. Here's our theta. The 4 over the 5 means this is sine, right? So this is opposite over hypotenuse. So the opposite is 4. The hypotenuse is 5. Because it's in the third quadrant here. Oops, sorry. So because we're in the, what I was saying here is because we're in the third quadrant is where both the x and the y have to be negative. Means therefore this has to be negative. So in other words, sine of theta is negative 4/5. If you remember how this works, sine is always corresponding to your y coordinate. So if you're in the third or fourth quadrants, your sine will always be negative. Your cosine corresponds to the x coordinates. So if you're in the second or third, your x will be negative. So cosines will be negative for those, which is why this one was a negative 3/5 because it's a cosine and it's in the third quadrant. So just keep that in mind. That's the only reason they give you the quadrant part of this. All right, there's one more of the same type of problem here. So it says, what is sine if cosine is this? And we're going to do the same process. We're going to substitute it into the Pythagorean identity that we're given. So I'm going to write that and work that out. All right, so I went through and did my Pythagorean identity. So I took my sine squared plus cosine squared equals 1, and I substituted the cosine theta that they gave me. After squaring this, I got 2 over 4, which is the same thing as 1/2. So I just subtracted 1/2 from both sides, which left me with 1/2. And then to solve for the sine theta, I square rooted both sides. When you square root this, you get 1 over root 2, which we've learned we can't leave the root in the denominator. So I rationalized it. Hopefully you've done this enough times, you're starting to recognize it. It always goes to this. And then I went ahead and I looked, should this be positive or negative? So sine is our y value. It is located in the first quadrant. Everything's positive in the first quadrant, so it's going to stay positive. Over here, same concept. They gave me the sine theta value, so I squared it. I subtracted it to the other side. I got 0.36. Square rooted that and got 0.6. So I was done at that point. And then I just look. They say quadrant 4. Cosine is our x value, and in quadrant 4, our x value is positive. So stayed positive. And that's it for today. All right, so try these out and we'll see how it all goes.